Welcome to today's episode, where we dive into the fascinating world of GPU programming using cubecl, a new tool that combines the power of Rust with high-performance computing. If you've ever felt overwhelmed by the complexity of optimizing compute kernels for different platforms, you're not alone. So, let's explore how cubecl is changing the game. Today, we have a compelling topic to tackle: writing GPU code easily and efficiently with cubecl. Now, you might be wondering, what's cubecl? Well, it's a framework that allows developers to write GPUs using Rust, embracing features like zero-cost abstractions and making it much easier to craft maintainable and flexible compute kernels. So what makes cubecl stand out? For starters, it fully supports functions, generics, and structs, and is adding support for traits and type inference. Imagine being able to write code that can naturally run on a GPU without losing the ergonomics that Rust provides. Let's talk about a real-world example of how this works. You simply annotate your functions with the cube attribute, signaling that they should run on the GPU. Think of it like flipping a switch that tells your code to take advantage of the parallel processing power of a GPU, which can massively speed up calculations. For instance, the GELU activation function is used frequently in deep learning. Cubecl lets you launch this function with a straightforward setup that allows automatic vectorization for improved performance. Isn't that wild? You can focus more on what your code does and less on how to make it run on different hardware. This brings us to the project's core philosophy: ease of development across platforms. When developing high-performance applications, you traditionally have to write separate kernels in different languages for different hardware, like CUDA for NVIDIA or Metal for Apple devices. Cubecl, however, acts as a bridge, allowing you to write once and run everywhere. And this leads us to another intriguing feature of cubecl: automatic vectorization. Here, the framework intelligently determines how to optimize your inputs for better performance without adding complexity to your code. It almost feels like magic, right? Now, for those of you who might be a bit tech-savvy, let's dive into some of the nitty-gritty. Cubecl leverages Rust procedural macros, setting it apart from the traditional compilation process. Instead of generating intermediate representation, IR immediately after parsing, it creates new functions in Rust. This means you can inject compile time optimizations seamlessly, opening doors to configurations that enhance performance vastly. But hold on, we're not done yet. Another compelling element is called auto-tuning. This nifty feature tests various configurations at runtime to find the most efficient ones for your specific hardware. Imagine getting the best performance just by letting your application do a little trial and error during startup. It caches this information so it doesn't have to do it again every time you run the app, improving responsiveness right off the bat. So whether you're working on deep learning, scientific computations, or any area requiring heavy calculations, cubecl promises a smoother journey in developing optimized applications. The project is still in alpha and evolving, but it holds the potential to revolutionize the way we think about GPU programming in Rust. As we wrap up, I encourage all tech enthusiasts and developers out there to look into cubecl. The landscape of high-performance computing, especially in Rust, is expanding, and there are opportunities to contribute and, even better, this innovative framework. Outro music kicks in. That's all for today's episode. We've explored the innovative world of cubecl and how it blends the power of Rust with high-performance GPU programming. Stay curious, keep learning,